This video goes over how to convert between the standard equation of a parabola, y equals ax squared plus bx plus c, and the more useful graphing form of the equation of a parabola, which is the one that we've been looking at so far. Just like an equation of a line, we can also write the equation of a parabola in standard form, but it's not very convenient when we have the equation because we'd have to go through a table of values. What we want to do is be able to convert between the two forms quickly and efficiently. So if we're given an equation of a parabola in vertex form, we can change it to standard form by expanding. X minus 2 all squared. Making sure that you use FOIL appropriately, first, outer, inner, last, would give you x squared minus 2x plus 4 minus 3. And that we can simplify to x squared minus 4x plus 1 would be our equation of the parabola in standard form. In order to go back the other way, we're going to do a process called completing the square. Our whole goal is to make our first two terms into a perfect square trinomial. So we can factor it, and then the 1 is just going to be the extra part at the end. So our first step is to factor out a from the first two terms only. Now in this example, our a value is 1, so we don't actually have to do any factoring here. Our next step is to add and subtract half of the middle term squared to form a perfect square trinomial. So usually what I do on the side is I'm going to just figure out what my b value is, which is 4, just the absolute value of it. And then I'm going to do b divided by 2 and then square. So 4 divided by 2 squared, which is going to give me 4. Now I'm going to manipulate my equation by adding 4 and subtracting 4. And then I still have my adding 1 over here at the end. So because I've added 4 and subtracted 4, that's the same as adding 0. So I haven't actually changed my equation at all. So now, if I look at these first three terms, I've created a perfect square trinomial. So I can factor this as x minus 2 all squared. I'm left over with my last two terms here, minus 4 plus 1, which is going to give me minus 3. And so I've successfully changed from standard form back into vertex form. So let's do a couple more examples. So this question is asking me always to convert from standard form into graphing or vertex form, and I'm going to complete the square. So my first step would be to factor out a. My a value is 1. I don't have to do this step. Then I'm going to identify my b value. I'm going to divide by 2 and square it. So 6 divided by 2 squared, which is going to be 9, because that gives me the term that I can add and subtract to create a perfect square trinomial. My next step is going to be to write the perfect square trinomial in brackets. So x plus 3 all squared. And then I'm going to simplify my remaining two terms, minus 16. Let's try another example. Here I have an a value that is not equal to 1. So my first step is going to be to factor out that value out of the first two terms only. So now my next step is to identify my b value. In this case, it's 8. Then I'm going to do b divided by 2 and square it. So 8 divided by 2 and then squared would give me 16. And now I'm going to add and subtract 16. It's important to do this inside the bracket because that is where you are trying to create that perfect square trinomial with those first two terms of your original equation. So now what I can do is write those first three terms as a perfect square trinomial and I still have this minus 16 left over, but because it's in the brackets, when I take it out, I have to remember to multiply by whatever I factored out initially. So simplifying this into vertex form, I would have 3 times 16 would be minus 48 minus 1, would end up being minus 49. Okay. So the important step is to make sure to keep everything inside the bracket after you've factored. Second important step is to remember to multiply that last term that you're subtracting by whatever you factored out initially. Let's do a couple more examples. So here again, I have an a value of 2. So my first step is going to be to factor out 2 out of my first two terms. Again, I'm trying to create a perfect square trinomial. So in order to figure that out, I'm going to look at my b value inside the brackets, and I'm going to divide it in half and square it. So 4 divided by 2 squared is going to give me 4. This is just telling me what I can add and then subtract to create that perfect square trinomial. So this b over 2 squared, all I am is using the property of how I know that the b and c values are related in a perfect square trinomial. So my next step here is going to be to factor the perfect square trinomial. I'm going to take what I factored out, multiply it by my last term, and then my last step is going to be to simplify those two constants, which gets me my vertex form of the parabola. Our next example here has a negative in front. My approach is still the same. I'm going to factor out negative 2 from my first two terms. I'm going to take my b value, divide it by 2, and square it. Which gives me 1. And then I'm going to add and subtract that so that my first three terms form a perfect square trinomial. My next step is to factor the perfect square trinomial, and then I'm going to multiply whatever I factored out by my last term. So plus 2 plus 5. And then I'm going to simplify my constants by adding them together to get my final equation in vertex form. Okay, one more example here with just one negative. So that still counts as not equal to 1. So I have to factor out negative 1 from my first two terms. My next step is going to be to identify my b value and then divide it in half and square it, which would give me 25. And now I've got x squared plus 10x plus 25 minus 25, because again, I'm trying to create a perfect square trinomial in the first three terms. Because I've added 25 and subtracted 25, I haven't actually changed the value of the equation. My next step is going to be to factor the perfect square trinomial, and then I'm going to take whatever I factored out, multiply it by my last term to bring it out of the brackets, and then I can add my constants together to get my equation in vertex form of the parabola.